In our solar system, there are two moons that look like UFOs, and no, it's not April Fools. Welcome to my channel. These mysterious moons of Saturn called Pan and Atlas are unlike any other moons in the solar system. They are covered with long, thin ridges that make them look like flying saucers or giant ravioli. And scientists have finally come up with an answer as to why they look so bizarre. The main rings of Saturn are opaque to transparent and over 6,000 miles wide. That's wider than Earth's entire diameter. But don't be fooled by their apparent simplicity. This ring system is one of the most complex structures in the solar system. It is made up of countless small pieces orbiting the planet at different speeds and at different distances from the planet. These range from small particles of dust to house-sized chunks of ice and rock. Some moons of Saturn have even been found to be partially made out of this ring material, and now scientists think they know why. The most likely explanation for why the moons look like UFOs is that they have been stuck to with ring material. Scientists believe that this happened when these moons passed through the ring and the material stuck to them. But here's the thing, Saturn has dozens of known moons and many more awaiting confirmation. So why did this happen to Pan and Atlas and not the others? Well, that's what scientists are trying to find out. Atlas and Pan are two of Saturn's inner moons, and both are roughly 30 miles across. Atlas orbits just outside the main rings of Saturn at a distance of about 140,000 miles from the planet, while Pan orbits closer to Saturn at a distance of 130,000 miles. Both moons orbit very close to the same plane, which is also where the rings of Saturn lie. Atlas was discovered by the Cassini probe in 1980 and named after the Titan who held up the sky in Greek mythology. Pan was also discovered by the Cassini probe in 1990 and was named after the Greek god of the wild and rustic music, obviously because it looks like a flute. While Pan and Atlas are similar in size and location, they do differ in shape. Atlas is shaped more like a ball, while Pan has an unusual elongated shape. It's Pan that has the more prominent ridges, which are up to 2 miles high. When the Cassini spacecraft flew by Pan in 2017, its cameras captured images of the moon's surface that revealed this strange structure. The images showed that the ridges stretched from one side of the moon to the other, and this suggests that whatever caused them must have been very long and thin. Scientists were baffled at first and came up with all kinds of explanations for these mysterious ridges. Some thought that the ridges could be caused by tectonic activity, such as the moon cooling and shrinking over time. Others suggested that they could be the result of impacts from meteorites. However, none of these theories could explain why the ridges were only on one side of the moon. And then something quite unexpected happened. When scientists took a closer look at the images of Pan, they noticed that some of the ridges had a white substance at their tops. And this substance looked awfully familiar. It was the same material that makes up Saturn's rings. This discovery led to a new theory, which is that the ridges are actually made out of this ring material that is stuck to the moon. If this is true, then it means that Pan has been stuck too with material from the rings of Saturn. Scientists think that this could have happened when Pan passed through the rings and the material stuck to it. But here's the thing, Saturn has dozens of known moons and many more awaiting confirmation. So why did this happen to Pan and not the others? Well, the answer may lie in Pan's orbit. You see, Pan orbits within the main rings of Saturn, while the other moons either orbit above or below the rings. This means that Pan is constantly interacting with the ring material, which makes it more likely that it would get stuck to with it. But this still doesn't explain why Pan has ridges and the other moons don't. To understand this, we need to take a closer look at how exactly Pan orbits Saturn. Pan orbits the planet in a peculiar way. Its orbit is highly elliptical, which means that it comes very close to the planet at times and then pulls away to a great distance before coming back again. It also orbits Saturn in a retrograde motion, which means that it moves in the opposite direction to the planet's rotation. This means that when Pan gets close to Saturn, it is moving very fast. As it approaches the planet, its speed increases until it reaches a maximum at the point of closest approach. After this, its speed begins to decrease as it moves away from the planet. So when Pan was passing through the rings of Saturn, it would have been moving very fast. This would have created a strong downward pull, which would have caused the ring material to stick to the moon's surface. Scientists think that this is why the ridges are only on one side of the moon. They formed as the ring material piled up on the side of the moon that was facing Saturn as it approached the planet. But why did the ring material form ridges instead of just covering the moon evenly? Well, scientists think that this could be due to the shape of the moon itself. You see, Pan is not a perfect sphere. It is slightly elongated along its axis of rotation. This means that the moon's gravitational pull was stronger at the poles than at the equator. As the ring material stuck to the moon's surface, it would have been pulled into ridges by this gravitational force. The material would have piled up at the poles until it reached a critical point, and then it would have begun to flow down the sides of the moon. This would have created long, thin ridges that stretched from one side of the moon to the other. But what about Atlas? Why does it look like a ball if it orbits in the same region as Pan and is also similar in size? Well, scientists think that this could be because Atlas does not interact with the rings of Saturn as much as Pan does. Atlas' orbit is less elliptical than Pan-S, and it does not take it as close to the rings. Additionally, Atlas moves in a prograde motion, which means that it moves in the same direction as Saturn's rotation. This means that when it passes through the rings, it is not moving as fast as Pan, so it is less likely to get stuck too with the ring material. However, scientists say that more observations are needed to confirm this hypothesis, so there you have it. The strange ridges on Saturn's moons, Pan and Atlas, are most likely caused by material from the planet's rings sticking to them. This happens when the moons pass through the rings and the material piles up on their surfaces. The exact mechanism by which the material forms ridges rather than covering the moons evenly is still unclear and will require further investigation. But one thing is for sure, Saturn's rings are truly a fascinating and mysterious phenomenon. Perhaps the moons Pan and Atlas are just the tip of the iceberg when it comes to the secrets they hold. Who knows? Maybe one day we will be able to unlock all of the mysteries of Saturn's rings and discover even more amazing things about our universe. What do you think about the latest discovery? Let me know in the comments. And if you enjoyed this video, please hit the like button and subscribe to my channel for more videos like this. Thank you for watching, and I'll see you next time.